Okay, so 38. Again, this is harder because if you look at the y-axis, that where it crosses is not a max. And where it crosses is not the origin. So you got a phase shift for both cosine because the max is over here. And you also have a phase shift for sine because the x-intercept is there. So this has phase shifts for both. That makes this way harder than the worksheet we did yesterday. So we're gonna do one at a time, and we're gonna get both equations, and we're gonna check them. We're gonna check them on our graphing calculators, okay? So here's what we're gonna do. We're gonna find a period first. I want to find a period. So if you look, all of these have a top hump and a bottom hump, so they're all one period, or they're both maxes or mins or whatever. So the period is going to be the right value minus the left value. So this is going to be 3 halves. My period is going to be 3 halves. Everybody okay with that? My tick marks, I'm going to get my intervals on here. My intervals are going to be the period divided by 4, which is going to be the period times 1/4, which means my tick marks are going to be 3/8 apart. 3/8 apart. Do we have a question yet? Okay, so my first tick mark is this 0 right here. I'm going to start there. My next tick mark is going to be the max that is right there. My next tick mark is going to be a 0 right here. My next tick mark is the that down there, and then this is my last tick mark. So my first tick mark's at a half, right? How far to the right of that am I going to get my next tick mark? How far am I going before I get to this max up here? It looks like I probably should have made it over a little further to the right. How far am I going over here to get to this tick mark? What thing tells us how far apart the tick marks are? The interval. How far am I going to the right of -1/2? 3/8, right? We said that's the tick marks. So I got to take -1/2 plus 3/8, which getting a common denominator is -4/8 plus 3/8, which means that -1/8. So I know this tick mark right here is -1/8. Now, what am I going to add to -1/8 to get this 0? How far am I going from this tick mark to the next tick mark? 3/8. So then I'm going to take this -1/8, and I'm going to add 3/8 to that again, which is going to give me 2/8. So you could write 2/8 here, or you can reduce that to 1/4. You see what I'm doing here, finding where these marks are? Then I got to take that 2/8, or 1/4, and I got to add 3/8 again to it to find that one. I actually could quit right there. I don't really need them. This will be 5/8. So this tick mark where that min is 5/8. And then if I add 3 more eighths to that, that's 8/8, which is the 1. So you see how it checks out, right? So are we thumbs up with what I got so far? Okay, so now I'm going to do the cosine graph first. So I'm going to do the cosine graph, and I'm going to get rid of all this stuff over here. But that shows me where the tick marks go to get my critical numbers, my max, mins, and my zeros. So that's what you got to figure out first. So what I'm going to do is, we know cosine starts at a what? A max. So what I'm going to do is, I'm going to bring my y-axis over here, so it's going through that -1/8. I'm going to call this y prime. And what's that make my phase shift? Can anybody tell me what my phase shift is on this? -1/8. I moved it to the left 1/8. Okay? So my phase shift, normally it's y, but I had to go left 1/8. So my phase shift's -1/8. Okay, so we're going to do cosine first. Okay, now let's go ahead and get our d value. D is the max. I don't know if she told you this or not. I don't know what she told you. It's the max plus the min divided by 2. So d is going to equal 4 plus negative 4 divided by 2, which is 0 over 2. And 0 divided by any number is 0. 0 divided by 0 is not 0. That's indeterminate. It's called an indeterminate. We learn how to deal with those more in calculus. Okay, so D is 0. So if you want, you can come out here to the right of the parenthesis and put plus 0, but 0 doesn't change anything, so I'm not going to. I'm going to go ahead and put my Y here. Now I'm going to find my number that goes in front of this, my A. A comes from the amplitude, right? So the amplitude is how much here? 4. Is 4. So what that means is A is either going to be a positive 4 or a negative 4, and I got to determine which one it is. So cosine normally starts where? At the max. Is this starting at the max? Right here, is that the max? Yeah. So that means I use which 4, positive or negative? Positive 4. Now, if I had to move my y-axis over to here and made it here, and I start at a minimum, that would make that negative 4. Do you see the difference? So if you start at the min, you got to make your A negative. If you start at the max, your A stays positive for cosine. Are we thumbs up on that? Everybody show me one or the other. All right. Now we want to find B. So again, I don't know what she showed you, and I probably should go back here. I kind of messed up and put this in the wrong place because I was doing calculus and I knew I wanted to do this. I want to go back here to something I hope she told you. So what I hope she told you was, in order to get B, we have this for period, right? So if you multiply the B over here, take B times period equals 2 pi, and then you divide by period, B will be 2 pi divided by the period. Okay? Did she tell you that? Yeah. Good. So, you know what? I'm going to move my, I wish I wasn't filming this now, but I am. I want to move that other thing that I just worked on closer to this so that it doesn't take so long to go back and forth. If I can find where it is. Oh, there it is. All right. So now I got it right beside it. Okay, so now I'm going to go back. And I'm going to find my B by taking 2 pi divided by the period. So if you remember up here, we found the period was 3 halves, right? So B is going to equal 2 pi divided by 3 halves. So I take 2 pi divided by 3 halves. So you're supposed to take and multiply by the reciprocal of 3 halves. So it's 2 pi over 1 times 2 over 3, which is going to be 4 pi over 3. So this is going to be 4 pi over 3. Question on that? How many are thumbs up on that, I guess I should say? So this, yeah. So this is going to be harder because the numbers are going to be a little crazier. Okay, I'm going to go back over here and show you how to find C. C comes in down here with phase shift. You must find B before you find C because you have to use B to find C. So again, normally we start on this problem. We normally start and we let C be the negative part. I'm going to move that C down here to the B part. And then when I multiply that negative B over here by phase shift, that gets C all by itself. You see that? So C will equal a negative B times the phase shift. Does that make sense? You can plug all this stuff in right here and then multiply the denominator over if you want. You can do that. If you're not sure what I'm talking about, let me know. So what I just said there was C is equal to negative B times the phase shift, right? Okay, well, we just found B was this 4 pi over 3. So we're going to put in negative 4 pi over 3 for this. And then we find the phase shift was this right here earlier. Then we say we move this over from the origin to the left, negative 1/8. So I got to put negative 1/8 in for that. Now, a negative times a negative is a positive. this 4 will reduce with that 8 to a 2. So when I multiply straight across, I get 1/6. There's my C. So I put plus 1/6 in here for my C. We already said way over here that D was 0. So you can put plus 0 out there if you want, or you just leave it like that. So there's the cosine graph, the cosine equation, I'm sorry. Now you could have moved your y-axis over here and had a little bit of a different, that would have changed your 4 and that would have changed your C. Your B won't change. Yes?
Well, this is a pi in that equation.
Yeah.
So, like what happens with C is negative 4 pi.
Oh, I left the pi off. Thank you. I messed up. That should be pi over 6. Oh, I'm glad you did that. It would have worked out. When we checked it on our calculator, we found it was wrong. Thanks, man. You saved me. All right. So there's that part. Now we're going to start almost all over. I don't know what Miss Perkins told you again, but I'm going to tell you this, and you ought to write it down. B and D do not change. B and D do not change. They stay whatever they are in each problem the same. So what I know right now is for my sine graph, I know y equals something sine, and this 4 pi over 3 is my B, so it is exactly the same. This plus 0 out here is exactly the same. Okay? Now, we're going to get rid of this little dashed line going up here, because now we're looking for the sine graph. Where does sine graph start? It starts at the origin, so I got to find an x-intercept. How many x-intercepts are in this picture?
3.
There are 3. You can pick any one you want. I'm going to pick the closest to the y-axis. Okay? So that means I'm going to go over here to this one right there. So I'm going to draw a fake one in there. Now, if you pick a different one, your equation will be a little different because your C will change and your A will change, probably. All right, so we are starting at this, we are starting at this origin right here. Now, usually sine goes from a 0 to a what? Max. Go to the right. If I follow this graph from the right from that 0, am I going to max? That means it's been reflected over the x-axis because I'm going to amend. How is that going to affect the A? That makes the A negative because a negative reflects it. So I got to put a negative there. Now, if you'd have phase shift to this one, everybody look up here real quick. If you'd have phase shift to this one, your 4 would have been positive because it's going to a max. You see that? If you'd have shifted to this one, it would have been a positive because it's going up to a max there. Okay? All right, now I want to find C. Well, here's my phase shift right there. So the phase shift on this one, the phase shift on this one is 1/4. You don't see it? And now I'm going to go and use that same formula I had a little while ago to find C for the blue part. So the C is equal to a negative B times the phase shift. Well, the B is still 4 pi over 3, so I still have a negative 4 pi over 3. But this phase shift is now this 1/4, so I got to multiply that by 1/4. So I hope you see these 4's cancel each other out all the way. So this would be negative pi over 3. So I put in here negative pi over 3. I'm done. That's both of them. Now get your calculator out and do this with me. We're going to check this out and make sure we got this graph right. So what I want to do is I want to type those 2 equations. Where's my camera? There it is. Okay. So I want to type it. I'm going to make this smaller. I want to type these 2 equations in that's down there at the bottom, if I can get them. Where can I see them? Okay, so I'm going to type those into my calculator. And one thing you need to know is you should go to mode right now. And when you're graphing trig functions, can you guys see that? Mode has to be in radians. If you are going to graph sine, cosine, tangent, any of those, you got to be in radians. So make sure you're in radians. Then go to your y equals. I'm going to leave these two in my calculator because they're calculus problems that I might get asked later. So I'm going to go down to y3. And I'm going to type in 4 cosine. Then I'm going to make, you got to put 4 pi in parentheses on yours. And then I'm going to put alpha y equals 1. And I'm going to type in 4 pi over 3. And put my, I guess I'm going to go, let's do this. 4 pi x. 4 pi x over 3, or you could put 4 pi over 3 times x, and then minus pi over 3. You have to use the divide button because your calculator doesn't have the fraction button on it. So there's the cosine equation. Then I'm going to do the sine one, which is negative 4 sine 4 pi over 3, 4 pi x over 3, minus pi thirds. Okay, I'm going to graph them, and I'm going to graph this, and it's going to look weird to you. So here comes my first graph. That's my cosine graph. Can you guys see that or not? Yes or no? Can't hear you. There goes my cosine graph. Now, why should my sine graph's going to be coming now? Can you guys see it? I don't know if you can see it or not. Oh, I don't have a go-to syntax error. I typed something wrong, maybe? Oh, I forgot the 3 didn't come in. Oh, I typed it in the top. Okay, my bad. Typed it in wrong. Now we got to watch all this crap again. I'm going to bring my picture thing over so you can see it better. So there goes the original one, the cosine one right there. And maybe I should have showed you something else here, but anyway. Now, look at that. What does that mean right there? Can anybody tell me? That's the second graph right there. Can anybody tell me what that means? We wanted the equations to be the same equation, right? What does that mean? It means we got a problem, right? If it was going to be the same, what would that second graph be doing compared to the first graph? It'd be right on top of it. Do you see it's not right on top of it? So that tells me that I've got a mistake. So if you type these into your calculator and you get something that looks like that, there's a problem. Now, I also like comparing it to my graph they give me. Why does that look so different than the graph they give me? Can anybody tell me? Yeah? Well, see, this graph goes from negative 10 to 10 and negative 10 to 10, right? Look at my window on the graph over there. Doesn't it go from negative a half to 1? And doesn't it go from negative 4 to 4? So if you change your window and you go from negative 0.5 to 1, and you go from negative 4 to 4, that will make it look more like the original graph. Now this is going to help me more. I hope. Okay, so which graph is more accurate? Which one is the right graph? Can you tell me? Is it the first one or the second one? What? The second one. Do you see how the max is to the left? Right? So that means I've got a problem on the right one. What do you think my problem might be on the right one? What is the right one compared to sorry, I should say the darker one compared to the red one? I think it's black and red, but you can't tell from here. What is there that's different? Somebody help me. Phase shift. It's moved over to the side, right? So that tells me we made a mistake on the first graph on the phase shift. So we got to go find the mistake now. Now I wish I hadn't erased it. Because yesterday I made a mistake on purpose when I was doing this, and this one I didn't do it on purpose. Okay, so this pi over 6 up here, I don't believe is correct. So we got to go back and do this problem over, at least the C part. Okay? So let's check it out here. So I want to check my phase shift again. We're going to go back to the red one. My phase shift is, yes, it is -1/8. Let's go back to red. So that was the original phase shift. Was -1/8. I didn't get the red. And my C value, again, my C value is supposed to be a -b times the phase shift. So let's see what we did wrong here. All right, so we got C is going to equal -4 pi over 3 times -1/8. See, those reduce to 2. That should be positive pi over 6. Isn't that what I had? Did I type it in wrong in my equation? I don't think that's wrong. I did type it in wrong. Nobody yelled at me. Look what I put in my equation. See right here what I put in there? See what I put in for that part? I screwed my denominator up. Now see, I wouldn't have known had I not seen the graph. So I'm going to go in there and fix that 3 in the denominator to a 6 because that's what it was supposed to be. Now let's graph it again. So here comes the first graph. Okay, that is still not right because you notice the max is on the wrong side. Oh, I got a negative? Okay. Thank you. Oops. I'll go back to y equals. Let's put a plus in there. Let's try that. Man, that thing's graphing slow. I wonder why it's so slow. Oh, that looks much better. Thanks for pointing that out, Bert. So my typing skills need to improve, huh? Usually graphs a little faster. Now let's look at, here comes the second one. Can you see it covering up the first one? Can you see it going over it? That means if they're right on top of each other, that means we are good to go. That means those two equations are the same equation. Even though they're written differently, they're the same thing. They're equal. So do you see how your calculators can help you if you make a mistake that you can check? Actually, I didn't make a mistake except for my typing. Like I said, I didn't do it on purpose, and I typed it in wrong, not on purpose. All right, I'm going to shut this video off. But that is what you got to do on some of these problems where they have a phase shift for both. They are harder.